Hi everyone, welcome to my channel. This channel is all about data analysis and finance. I will sharing tips, tutorials and insights to help you make smarter financial decisions using data. Don't forget to subscribe and hit the bell icon to stay updated. Today I'm going to present this review in descriptive statistics as a first and basic step in data analysis. So let's get started. First, we're going to talk about the types of data. There are three types of data. The first one is cross-sectional data. The cross-sectional data is the data collected from different units at a specific point in time. I mean, in this type, we fix the time, or we take a specific point in time, and we observe different units. For example, we can observe the inflation rate as a variable for different country in a specific point in time, for example 2000. Okay, I will show you an example of the cross-sectional data here. Like you see, we have person ID, we have a group of people of individual. We have 500 individuals in data set, and we observe the income, the annual income in $1,000. So for in the year 2000. So here we fix the time 2000 specific point in time, and we have a different person. I mean several individual or person. We have 500, and we observe the income of each individual. So for example, in 2000, the individual or the person one has an income of $50,000, and the person two $65,000, and so on. Okay, this is an example of cross-sectional data. Let's move to the second type. The second type is time series data. The time series data is the data collected from a single unit over a time period. I mean, here the time change and the unit remain the same. For example, we can observe the inflation rate from for Algeria or for United States from 2000 to 2022. Here we talk about time series data. So I show you an example of time series data. Here is our example. So like you see here, we have time period. So we have 10 months in 2019, and here the first variable, the second variable. So the first variable is oil price. So we have here the oil price change from March 2019 to December 2019. So like you see, the oil price is our section, and the time change from March 2019 to December 2019. So here, this is our time series. Okay, and the second variable is exchange rate. Also, we have here dollar euro exchange rate. Like you see here, we have the value of a euro dollar exchange rate over time, over the time period. I mean, in March, from March 2019 to December 2019. Okay, this is a time series, the first one and the second one. Okay, so let's move to the third type. The third type is a panel data. The panel data is the combination of cross-sectional and time series data. So we have a cross-sectional, we have time series combined into cross-sectional data. This data is collected from different section and from multiple unit and from from different point in time. Okay, let's see an example here of panel data. Like you see here, our variable, we observe the GDP growth rate for different country. So here we have USA, Canada, UK, Germany, Japan, and we have also the time frame. The time frame for each country is 2019 to 2021. We have 3 years and 5 country. So we combine there's 5 country and there's 3 years time period. We get the time series. So if you see here, we have the time series for USA and the time series data for Canada and for UK and for Germany, Japan. So we grouped there's 5 country, there's 5 time series in the same data set. So this data set is called panel data. So this is the panel data, the GDP growth rate for 5 countries from 2019 to 2021. Okay, this is the panel data, an example of the panel data. So let's move to right now we're going to talk about the descriptive statistics. So I will give you a concept of descriptive statistic and its measure and how we calculate this different measure. So the descriptive statistics provide a comprehensive summary of key characteristics of a data set, helping economists and researchers to better understand the central tendency. When we talk about a central tendency, we talk about the mean, the mode, and the median. I will explain this later. And we have the spreadness of the data and the asymmetry of data and the flatness of the data. They are analyzing in econometric studies. So here I explain you the different measure of descriptive statistics. So the first one, the central tendency measure. We have in the central tendency measure, we have mean, median, and the mode. For the median is the mean. Sorry, the mean is the average. Is the average. We can call the mean. We can call it the average. Example of the mean is the average income of group of people. We have a group of people. There's different people have their wages, their income, and we seek to know the average income of this group of people. Okay, so for example, we find $2,000. We say that the income of this group of people is around 2,000. And for the median is the middle value in data set. For example, the middle value of house price in a city. For example, we have the house prices in, for example, in New York, or for example in Paris. Then we look to and we try to find the middle price. So we calculate the median, and we say when we calculate the median of this house price value, we say that the price of house in, for example, in New York is for example $400,000. And about the mode is the most common value in the data set. How many times this the value of the variables is repeated in the data. the frequency, the value which is repeated the most, we say that this is the mode. Okay, the most common shoes example: the most common shoe size sold in a store, for example, is 39 or something like that. Example of spreadness measure. Spreadness measure variance. We have variance and standard deviation. And the last one is examples of asymmetry and flatness measure of the data. We have skewness and kurtosis. So in the following section, I'm going to explain all these measure, or these 7 measure in details. So let's start from with the mean. The mean or the average, it is calculated by adding up all the value in a data set and dividing by the number of observations. The mean provides a single numerical summary that represents the typical value in the data set. The mean of is x bar equal the sum of xi, I from 1 to n, divided by n, number of observations. Here we have an example. So let's open the Excel file. I will explain you how to calculate this mean. Okay, so here, like you see here, we have a time frame, and I will make it larger. Yes, like that, it's bigger. So here we have the time frame, and here we have our variable x, which is the money spent by individual x. So to calculate, to know the money spent by this person, it's around which value, we calculate the mean. So we can say that this person spent around for example $40 by each day. Okay, so to calculate the mean, we have choice to the first one. We can follow the formula here. Okay, we can follow this formula. So to follow this formula, I will show you how you do it. So first you calculate the sum. So you just type equal, then you choose the sum, SUM in English, but here it's in French, so it's sum. So here you it's type equal, then choose the sum, SUM, then select all the value of the data set, then click enter or click enter or OK, then you get your sum. Here we have the sum of all this value. Okay, we have the sum. Okay, then after that so here, what does it mean? 387. It means the sum of xi. Then to continue with this formula, we divide by n. We divide by n. N is the number of observations. So here the number of observation is 10. So we just type 10. We choose our sum, the sum of all the value, then divide by number 10. Divide by 10. Then press OK. Yes, we have our mean is 38.7. Means that this person spent around $38.7 each day. In January 1, I mean the average of money spent for this individual is 38.7. There is another method to directly calculate this mean by using the function. So I try to calculate it here. Here, okay, so we just type equal, then we go to function, choose average, insert a function, then select or highlight all the value of the data set, then you press OK or enter. Here we go, we have 38.7. Okay, so the average or the mean of this data or the money spent by this individual is 38.7. Then let's move to the second one, median. The median is the middle value. Like I said before, that it's the middle value of the data set when it is ordered from lowest to highest. So if we take this example and go to the Excel software to calculate it, here I show you how to calculate using Excel, and I show you in Excel directly. It's straightforward how to calculate median. So to calculate our median, we have to type equal, then we go to the function, and you choose the median, okay, insert a function, then highlight all the value or select all the value, then press OK or enter. So your median is 203. This is the middle value of the sales of star X. Okay, this is the median. And the third measure is the mode. The mode refers to the value or the values, because we can have one mode or several modes, okay, multiple modes. So the mode refers to the value or values that appear most frequently in a data set. In other words, it is the data point or points, different points, that occur with the highest frequency. Means that it appears at different time, in different time point, or the most common value in a distribution. So like I mentioned before, that we can have only one mode, so we say that it's unimodal, or two modes, so we say our data is bimodal, or several modes, so we say that our data set has a multimodal. Okay, our data set is a multimodal data set. Okay, when we have data with more than two modes. This is the measure of central tendency. Okay, so when we calculate this measure, I mean the mean, the median, and the mode, we get an idea about the value of our data set. It's around which value, and which value is most common, or or the value with highest frequency, and we can have also idea about the middle value. For example, if I say the oil price is something, then we find the median is $60. So we say that the oil price is about 60. The oil price middle price is $60 per barrel. Okay, that's the meaning of the three measures of the central tendency. Let's move to the sorry, I didn't show you how to calculate the mode. The mode, if we go here, we type equal, then we go to function, and we try to find the mode here. We can just write here MO, or here, right here, look, MO. So here we talk about mode multiple or mode simple. So I choose, for example, this. Then select the variable, the value, press OK. So according to this data, our mode is 141. So the value which is common in this data set is 141. Yes, like you see here, we have 141, 141, 141, 141. It's the most common value in the sales. Okay, so this is the three measure of central tendency. So let's continue with the measure of spreadness. So the measure of spreadness, like I mentioned before, we have variance and standard deviation. So the variance give us an idea about the degree of variation or fluctuation of our data. I mean the degree of variation or fluctuation of the data. For example, when we see a stock market price and we calculate the variance of stock price, then we get an idea about the degree of the variation in this stock market. Okay, so the variance is calculated using this formula. I mean, here we have 1 over n minus 1 time the sum of xi minus x bar square. Okay, and how we calculate it using Excel. Here I show you how to calculate the variance. If you want, we can calculate. Let me see. For example, if we want to calculate the variance of money spent here, so you have to go to another case and type equal and var, so the variance of a sample, var point s means the variance of a sample. So we choose variance of a sample, then we select all the value of our data set, then we press OK. So here is our variance. The variance of money spent here is 145.56. Okay, this is how we calculate the variance here. My opinion about this variance is very large. It's very large variance. Here I explained how to calculate this variance, and let's move to the standard deviation. Standard deviation measure the dispersion in a set of values. The standard deviation tells us how far each value lies from the mean, how far the data point are far from the mean. Okay, that's what means what the standard deviation tell us. So a higher standard deviation means or indicate greater variability. So if you have a high standard deviation, so you conclude that the data show a greater variability in in the opposite, Low standard deviation means that the value are close to are clustered close to the mean. Okay, so here is the formula. If you we try to calculate, or when you want to calculate standard deviation by hand, so here you have the standard deviation is the square root of the variance. Okay, so if we back to the standard the variance, so this is the formula of variance. So if we take the root square of this variance, we get directly our standard deviation. So when you calculate, for example, here, if we back to our example, I can just type equal, then looking for the square root, SQRT square root, but because my Excel it's in French, so I mean I have to write racine in French. Okay, racine of the variance, press OK. So our standard deviation is 12.006. This is the more simple method to calculate standard deviation. Okay, another method to calculate the standard deviation, we have our function standard deviation. So we type equal, then we type the name st, here it is, standard deviation, then we choose, or sorry, we select all the value of the data set, then we press OK. You see the same as the first method. So you have two methods. When you have your variance, you just have to take the square root of the variance, then you get your standard deviation, or you can calculate it using the this formula like you see here. Okay, as equal standard deviation, then you select the value of your data set. Okay, so this is about the meaning and the measure of the spreadness of the value of the data set. So right now we go to the last one, the skewness and kurtosis. So we start with skewness. Skewness measure the asymmetry of the distribution of the value in a data set. So when we calculate the skewness, we have to look, if we have skewness equal 0, means that the data is asymmetric. It means that the value we have before the mean, the value of the mean, and after the value of the mean, or I mean in the value we have greater than the mean, and the value we have less than the mean, are lower than mean, are the same. So we say here our distribution is normal distribution. And when we have a positive skewness indicates a right skewed distribution, or the tail on the right. Negative skewness indicates the left skewed distribution, or the tail is in the left side. I can show you here in this figure. So you have to put in your mind that the skewness measure the asymmetry of the distribution of value in a data set. The asymmetry it's compared to the mean value. Okay, so if we see here we have in the blue color, we have the symmetrical distribution. If you see here the value of the mean the number of the value, what we have before the mean and after the mean are the same. And here we have a positive skewness, or like I said before, the tails is in the right side. The tails is in the right. And we have negative skewness, the tails is in the left. Okay, this is the skewness measure. So we say here our data is symmetrical data, but about and the second positive skewness and the negative skewness, our data is not symmetrical distribution. And like I said before, that this data, this graph represents the normal distribution. Okay. We can also calculate it using, we can calculate the skewness using Excel. You just type equal skew and you choose your data set. I mean, you select all the value of the data set, then you press OK. Then in the skewness value will be appear in another cell. And the last one is the kurtosis. Kurtosis measure the flatness of our data set, or the degree to which the peak of the distribution is high relative to the normal distribution. So the skewness and the kurtosis we also compare to the normal distribution. The normal distribution, the skewness of normal distribution is 0. So if we find our skewness is less than 0, so we talk about negative skewness. If we find it more than 0, I mean 1, 3, 6, so we say that we have a positive skewness, means our data has right tails. And for the kurtosis of normal distribution is 3. The value of kurtosis in normal distribution is 3. So if you find your kurtosis is more than 3 or less than 3, so we can say that our data is not normally distributed. Sorry. This is the meaning of kurtosis. So here you see, like you see here, we have, this is our normal distribution. Okay, means the kurtosis equal 3. So this distribution, we can call this distribution mesokurtic distribution or normal distribution. Our peak, it's not high and it's not flat, mesokurtic. And for this one, we have our kurtosis is less than 3, so we talk about flatness of we talk about the flat data. The peak is flat, so platykurtic. And if your kurtosis is more than 3, means you have a high peak. So this data called the leptokurtic data. See. Okay. Here, like I said before, the kurtosis of normal distribution equals 3. The distribution is platykurtic when the kurtosis coefficient is less than 3. The distribution is leptokurtic when the flatness coefficient is greater than 3. Okay. Yes, this is negative kurtosis, mesokurtic normal distribution, and positive kurtosis high peak. So to know if your data is normally distributed, so you have to check if your kurtosis equal 3 and your skewness equal 0. So if you have skewness equal 0 and kurtosis 3 equal kurtosis coefficient equal 3, so you say that your data is normally distributed. Here it's an exercise, Excel application exercise sector-wise return. Calculate the mean return for each sector, calculate the standard deviation of return for each sector, determine the sector with the highest kurtosis. So here it's the data for this exercise. You can just how to say that, put your data in Excel and calculate in the same way like I show you in this video. So that's all for today. So I say I wanna tell you again that this is an introduction for this time series data, or this data analysis and finance. I will add others video in which I will show you or I will present you other topic, for example about the regression, about the how to conduct empirical study, and how to analyze your data using different model, using different technique in eViews and in Excel software. So don't miss out this interesting video and interesting explanation. Don't forget to subscribe and hit the bell icon to stay updated. So see you next time. Thank you for you all. Bye bye.